In this session, we will talk about and discuss molar mass. In other words, mass of 1 mole of a substance. In other words, mass of 6.022 times 10 raised to 23 particles of that substance. If you remember in a session, a couple of sessions ago, we talked about something called an atomic mass. Which is we defined in a very simple terms, mass of an atom. Then in the last session or the session before that, we talked about formula mass, which was the mass of a formula unit. In this case, molar mass therefore implies the mass of a mole. Now, what is formula mass? As we said, it's the mass of a formula unit. In other words, the mass of one particle, whether that particle is an atom or a molecule or a formula unit, but the mass of that one particle is the formula mass of that substance, mass of one formula unit of that substance. But when you have 6.022 times 10 raised to 23 of those particles in one packet, that which is called a mole, then the mass of this entire packet is called the molar mass. In other words, formula mass is like the mass of one single egg, but molar mass is the mass of a dozen, a packet of 12 eggs. And that is the difference between these two terms that is very important for us to understand. So molar mass is the mass of Avogadro's number of particles of a substance. Now, again, I'm going to ask you to remember what were the molar mass, what were the formula masses of these substances that we worked on a couple of sessions ago. Water. We calculated that its formula mass is 18.02 units of AMU. Please remember that. We also calculated the formula mass of sodium chloride to be 58.44 AMU. Once again, remember the unit. And another one we talked about is nitric acid, whose formula mass is 63.02 AMU. Do you remember how we calculated these? Exactly, these were calculated simply by adding up the atomic masses of every atom in one formula unit. Now the unit AMU indicates the mass of each particle, whatever that smallest unit, formula unit happens to be. This is the formula mass. But the mass of the mole of one of these substances is given in units of grams per mole. In other words, the mass in grams for 1 mole of that substance. Now this number, the molar mass of a substance, is equal in value to the formula mass of the substance in units of grams per mole. Basically, what that means is that if you take water as an example, if its formula mass is 18.02 AMU, its molar mass will be 18.02 grams per mole. 18.02 grams of water equals 1 mole of water. Similarly, molar mass of sodium chloride would be 58.44 grams per mole, and nitric acid is 63.02 grams per mole, calculated in exactly the same way. Okay, so go ahead and pause the recording while you calculate the molar masses for these compounds. Now, hopefully you realize when you were trying to calculate the molar masses of these compounds that before you actually do that, you need to have the correct chemical formula. If the chemical formula is not correct, the molar masses will absolutely be not correct either. So barium chloride chemical formula is BaCl2, and it's an ionic compound with a fixed charge cation, and if you calculated its molar mass, it came out hopefully to 208.23 grams per mole, because this is now molar mass. Tetranitrogen tetrahydride is a molecular compound that is not an acid. It has 4 nitrogens and 4 hydrogens, so the chemical formula is N4H4, and its molar mass therefore comes out to be 60.08 grams per mole. Now, once again, I would like to highlight at this time as to what do these numbers mean. This number basically is an equation. If you look at it in 208.23 grams per mole, it's an equation. It says that 208.23 23 grams of BaCl2 equals 1 mole of BaCl2. So it's like a standard equation for BaCl2. Similarly, N4H4 60.08 grams of N4H4 in this case equals 1 mole of N4H4. Once again, this is like a standard equation for tetranitrogen tetrahydride. So that is what we need to remember, that when we're looking at the molar mass equations as it's given, it's an equation which relates to units. In this case, like any other equation, any other standard equation, this equation relates moles of a substance to mass of a substance in grams, hence the term molar mass. Whenever you're dealing with any problem, any question that needs you to convert between moles of a substance to grams of that substance or mass of that substance, you would need to use the molar mass equation. For example, here's a problem. Here's a question that is asking us to convert between, once again, we're calculating the mass of iron 2 carbonate from moles of iron 2 carbonate. So once again, please notice the two units in question here are moles and mass. Hence, molar mass is what we need as a standard equation. Now, before you might realize that before you actually figure out the molar mass of iron 2 carbonate, you need to have the correct chemical formula for iron 2 carbonate. Yes, absolutely right. Since it's iron 2, that's Fe2 plus, carbonate is CO3 2 minus, therefore iron 2 carbonate is FeCO3. In other words, if you calculate the molar mass of iron 2 carbonate, the equation becomes 1 mole of FeCO3 equals 115.86 grams of FeCO3. Molar mass is always in grams for 1 mole. Okay, so now we are ready to set up this equation where, once again, as always, we are going to start with what's given and needs to be converted. In other words, 5.20 moles of FeCO3 needs to be converted to grams of FeCO3, meaning moles of FeCO3 goes on the denominator, so you can cross it out. Grams of FeCO3 goes on the numerator, so that you're left with it as the final answer, which is what we need. So 1 mole of FeCO3 has a mass of 115.86 grams. When you calculate this, the calculator answer comes out to be 602.472 grams of FeCO3. Are we done? No, we are not. We do have to round the final answer based on significant figures of the measurements given. So in this case, we are given 3 significant figures, so we need to round to 3 significant figures, and this becomes 602 grams of FeCO3 as the final answer. Okay, so here's another similar problem. In this problem, we need to go from pounds, which is another unit of mass, to moles of liquid nitrogen. Okay, so there are a couple of things we need to discuss and clarify before we actually solve this problem. Number one, mass is given in pounds, but please remember, molar mass is always in grams for 1 mole per mole. For 1 mole. Okay, so in other words, first thing we do have to keep in mind is pounds will need to be converted to grams, because otherwise you cannot use molar mass. The next thing that I would like to point your attention to is liquid nitrogen. Now, is this a compound or an element? Exactly, it is an element. If it is an element, nitrogen, what is the chemical formula of the nitrogen that is stable and exists in nature? From a few sessions ago, you need to remember that there are certain elements in the periodic table which I have already specified cannot exist as atoms in nature. They must exist as diatomic molecules. One of them is nitrogen. Now, this is something you have to know and remember. So please go back to that previous session if you've forgotten to write down which of those elements fall in this category. Okay, so nitrogen element has a chemical formula N2, not N, because if it is N2, its molar mass will be not 14.01 grams per mole, but 28.02 grams per mole. In other words, 1 mole of N2 has a mass of 28.02 grams. Okay, so now we are ready to set up this problem. We're going to start with, once again, what's given that needs to be converted. In this case, it is the pounds of N2, but we can't work with pounds. We do need to convert pounds to grams. Once you have grams of N2, we can now convert grams of N2 to moles of N2 using the molar mass equation, such that grams of N2 crosses out and we are left with moles of N2, and that's what we need to calculate. If you put in the numbers now at this stage, we know that 1 pound equals 453.6 grams. You were not asked to memorize this equation. This will be given to you in case you need it. But you do need to know that the molar mass means that 1 mole of nitrogen equals 28.02 grams of nitrogen. If you solve this, the answer comes out to be 0.412805139 moles of N2. How many significant figures should this answer be given in? Absolutely 3 significant figures. So when you round this, the final answer is 0.413 moles of N2.